Hello everyone, welcome back to my YouTube channel. So today we are going to solve day 29 problem of this month on LeetCode. Before starting, if you guys haven't subscribed my YouTube channel yet, then please go ahead and subscribe it. Now without any delay, let's get started with today's problem. Problem number 2818. Apply operations to maximize score. Okay, so let's read the problem statement first. You are given an array nums of n positive integers and an integer k. Okay, initially you start with the score of 1. You have to maximize your score by applying the following operations at most k times. Okay, so we have to choose any non-empty sub-array nums L to R, okay, that you haven't chosen previously. All right, then you have to choose an element x, okay, of this particular sub-array with the highest prime score. Now what is this prime score? Okay, so the prime score of an integer x is equal to the number of distinct prime factors of x. Okay, for example, the prime score of 300 is 3. Since see this 300 factors are 2 into 2 into 3 into 5 into 5. Okay, so we have 2 here. Okay, distinct 2, 3 and 5. Okay, so total 3 distinct prime factors are there. Okay, so that count is nothing but the prime score. Okay, so if multiple such elements exist, then you have to choose the one with the smallest index. Okay, so let's suppose this is a array. Okay, so in this array these are the prime scores of few elements. Okay, so for this element prime score is 3, for this element prime score is 3, and for this element let's say prime score is 2. Okay, so in this complete array highest prime score is 3, right? So you have to pick then this one, because this 3 is this number. Okay, this number is at 0 index, this number is at 1 index, this number is 2 at index. Okay, and this is nothing but prime score. Okay, prime score, and this is nothing but the element indexes. Okay, indexes. Okay, you can say here, let me I, okay, for indexes, and here elements, let's say x, y and z. So in that case you have to pick x, okay, because this element x is at index 0. Okay, and same way, if let's suppose prime score is 4, okay, then this particular subarray you have to just pick the element z. Okay, that simply means index 2. Okay, so here the prime score of an integer x is equal to the number of distinct prime factors of x, and the prime score of 300 is 3, because 300 factors are 2 into 2 into 3 into 5 into 5, so distinct are 2, 3 and 5. Okay, that's it. So, and if multiple such elements exist, then you have to choose the one with the smallest index. Clear, right? Then you have to multiply your score by x. Okay, so initially score is 1, right? So in this one you have to multiply the new score. Okay, so you have to multiply score by x. Okay, so this particular number, this particular element, okay, not with the prime score, not with the index, you have to multiply with that particular number itself. Okay, so here what is this nums L to R? So this denotes the subarray of nums starting at index L and ending at index R, both ends being inclusive. Okay, so L and R both are inclusive, right? And in the end we have to return the maximum possible score after applying at most k operations. Okay, and since the answer may be large, we have to return it modulo 10 to the power 9 plus 7. Okay, so I hope that you guys are clear with the problem statement now. Okay, so now here see this particular example number 1. So here if I first of all let me write the indexing here. So 0 index, 1 index, 2 index, 3 index, and then 4 index. Okay, then we have to calculate the prime scores. So prime score is nothing but the factors. Okay, factors of a particular number. So here for 8 I can write it like this: 2, then I will get 4 here, then here 2, then I will get 2 here, then I will get right 2 here, right? So 2 into 2 into 2, okay, is equal to 8, right? So distinct are just one element. Okay, 2 is there, so here prime score of this 8 is 1. Okay, and same way here for 3 prime score is 3 into 1, that's it. Okay, 1 only. And here for this 3 into 3 only one distinct element, 3, right? So here for this one it's also 1 only, right? 3 into 1, yeah, that's it. And for this 8, 2 into 2 into 2, 2 is there only, right? So prime score is 1 only. So prime score is 1 only, okay, for all the numbers. Okay, now in this case I have to apply two operations, k is equal to 2. So now here I have to select the sub array, right? And sub array should be non-empty. So in that sub array, since the scores are same, okay, prime scores, okay, this is nothing but ps, I can write prime scores. Prime score is just 1. So now in my sub array I'm picking the x. X is nothing but the value of that particular element. Okay, so I can do one thing now. I can just create one sub array of length 1, and in that length 1 sub array I pick 9 only, this sub array only, right? Because if I'm picking this one only, then in this particular subarray the prime score is 1, and that is maximum only, just picking one number only, right? So in my prime score I will get best answer if I multiply the initial score with 9. So I will get 9 is the max. Okay, there is no other possibility, right? Okay, I can't take this complete subarray, right? 8 3 9 3 8. I can take it complete. Okay, if I take it complete, prime score is just 1, then I have to pick the first one, na? Right? So here, see this line, if multiple such elements exist, you have to choose the one with smallest index. So that's why I'm starting from 9 itself. Okay, this is done. Then I can take one more. I can take this one as well, 9 comma 3. So in this one also, in this subarray, this is distinct from previous one. In this are also both having prime score 1 1. I can pick this number. Okay, so in this 9 I can multiply this again, element 9. Okay, 9 to 10, 9, I will get 81. So my output is 81. Okay, because we have to do two operations only, right? So that's it. I can also pick this 9 comma 3 comma 8. In this also I will get the max output 9 only, right? So it's my choice. So here, see, choose subarray nums 2 to 2. Nums 2 is the only element in this subarray. Hence, we multiply the score by nums 2. The score becomes 1 into 9 is equal to 9. That's it. Then choose subarray nums 2 to 3. Both numbers 2 and 3 have a prime score of 1, but nums 2 has a smaller index. Hence, we multiply the score by nums 2. The score becomes 9 to 9 is equal to 81. It can be proven that 81 is the highest score one can obtain. Okay. All right, so this is done. Okay, so now let's leave this for now. All right, so here how you calculate the prime factors of 180. Okay, so 180 if I write here, and then you have to do it like this now. 2, okay, and then you get a 90. Okay, then again it is divisible by 2 only, right? Again and again it's divisible by 2. Okay, but I have to calculate the score now. So this is one time. Okay, so 2 is one time. So after that, what I will do, I will first try to divide this number with 180. So here, see, 180 divided by 2, I will get 90. Okay, all right, and then 90 is also divisible by 2. Okay, so I get 45. So 45 is not divisible by 2 now. Okay, so with the 2 I reach to 45 and I increment my prime score to 1. Okay, with the 2 I increment my prime score to 1, right, and I reach to 45. Now next time, first time I'm checking with 2. Okay, right, because here in the problem statement, is equal to number of distinct prime factors of x. Okay, and we know the prime number starting from 2, right? 2 3. Okay, so now next time I have to check with 3. Okay, p is equal to 3. So 3 and previous number was 45, right? So 45 divisible by 3. Okay, so I will get 15. Then 15 also divisible by 3, so I will get 5. Okay, 5 is no longer divisible by 3, so I have to stop. Okay, so I have to increment the prime score to 2. Okay, so 2 into 2 into 3 into 2. So until here I get the result. Okay, now after that, p is equal to 4, composite. So here we don't need to check with the p is equal to 4, because here in the first step itself I divide with 2 completely. Okay, 180 divided by 2, 90. Okay, so after that I'm not dividing the number with 4. Okay, why I'm not dividing with the number with the 4? Because I have already divided that number with 2 into 2. Okay, that is 4 only, but I use the smallest prime factor. Okay, I use 2 into 2. Okay, instead of directly using 4, which is composite, I use prime number. Okay, 2 into 2, like that. Okay, so here p is equal to 4, composite, skip, because 4 is equal to 2 into 2, and we already removed all the 2's earlier. Here we have removed all the 2's. Okay, done. Okay, so here what I did, here 180. So with 180, 2 we get 90, then with 2 we get 45. Okay, that's it. Now after that you will not find any calculation with 4. Okay, because it's already done with 2 into 2. Okay, next time you did with 3. So 3 1 3, here you get 15, and then here 3 5 15, and then 5 is here. Okay, so here with the 2 you increment the prime score to 1. Okay, and then you just reach to 45. You just divide the number with 2. Okay, where until here it is possible, not until 45 it is possible, so just do it. Okay, then with the 3 you just did it. Okay, then p is equal to 4, we are going to skip it because it's composite. Okay, and p is equal to 5, we divide it. So here also we increment the prime score to 3. Okay, so here after that 6 8 9 10 11 12. Okay, these are the composite number. Okay, and we are going to skip it. Okay, because their prime factors 2 3 or 5 have already been removed, right? So this is a prime factor. Okay, 6 I can write it 2 into 3 now, so we have already checked with 2 and 3. Here 8 2. Okay, so with 2 we have checked. 9 we can write 3 into 3 now, so we have with 3 we have already checked now. So 10 also 2 into 5 we have already checked with 2 and 5. Okay, so here 2 into 6. Okay, we have already checked with 2 into, not 6, you can say 2 into 3 into 3. Okay, so with this we have to skip because their prime factors 2 3 or 5 have already been removed. Okay, okay, now same way here we get the prime score 3. Okay, so we have to stop until we get 1. Okay, and it's 1, so we stop. Okay, same way if you calculate the prime factors of 35, so you get start with 35. So here this is one step that I want to explain. Okay, mostly you know, right? So why I'm checking until 13. Okay, here I'm checking until 12 now. Okay, it should be until here less than. Okay, this one. Okay, so here see, first with 2, 35 is not divisible by 2, skip. Then we have to check with 3. Okay, so 35 is not divisible by 3, skip. Then 5. So 5 is divisible by 35 is divisible by 5, so we get number 7. Okay, then after that here we are checking just up to 5 now, up to 5 we are checking, then done. Okay, we come out of this. Okay, so now after that final check. Okay, final check we will do one more time. So if a number is greater than equal to 2, then now num is equal to 7. That simply means since 7 wasn't removed earlier, so it must be prime. Okay, so 5 into 7 now. So until 5 I checked. So here there is one more factor now, 5 into 7. So that's for that 7 I have to increment the prime score again. So final prime factor is 35, 5, 7, prime score is equal to 2. Okay, 1 is for this 5. Okay, increment prime score here, and then 7 is still left now, but we are checking until 5 only. Okay, so with the 2 we checked, we can divide, right? So here we increment prime score 1, then with 3 we can do we increment. Okay, with 5 we can do we increment, but here with the 35 I increment until 5 with 5. Okay, and I get 7. Then after it we didn't check because until here only we were checking. So in the final check I will add one more check in my code. Okay, if number is greater than equal to 2, then we have to skip. Okay, so this is nothing but how we calculate the prime factors. Okay, so why we are checking until this square root, okay, of that particular number. So here you can take that particular example now. So every factor of n, okay, so let's suppose you are n, so every factor of this n, so if I calculate the factors 2 12 2 6 2 3 and 3 1, okay, every factor of n greater than square root of n must be paired with a smaller factor less than square root of n. Okay, for example, if d is a factor of n, okay, so if d is a factor of n, let's suppose 12 is a factor of n, okay, then n by d, okay, n by d is also a factor, right? So if 12 is a factor of n, okay, then n by t, okay, so 24 divided by 12 we will get 2 is also a factor. Okay, 2 into 12, so we get 24 here. 1 into 24 we get 24 here. So see, this one number is always less than square root of n, and one number is always greater than square root of n. Okay, 3 into 8, same way 4 into 6. Okay, so this is happening. Okay, in case of 36 you can say both the numbers are same. Okay, here 6 into 6 you can write. Okay, 36 you write like this now. 2 then 2 1 here 8. Okay, and then here 2 9, and here 3 and 3 here, then here 3 and 1. Okay, so these are the factors. Okay, so from here, see, until here if I check now, if I checked until here, the smallest factor in each pair, if you see, is less than equal to square root of 24, which is approximately 4.89. So until here if I check now, so I will get all the perfect combination, because factors always comes in pair. Okay, so for 25 24, okay, if I'm calculating the factors, so definitely I will get, let's suppose this is my number x, so for this I'm calculating the factors, so they will always come in pair now, a into b. So if I am selecting this one number, okay, as n by d, okay, then here the next factor is going to be d itself. Okay, so that's the reason, right? So we have to check until square root of n. Okay, so actually this is very basic thing. Okay, so if we check the divisibility up to square root of n, we will find all the factors. Okay, so this is very basic thing actually. So all right, so this is done. Okay, then in my problem also I'm going to use one more thing known as monotonic stack. So here see this particular example. This is my array. Okay, 1 7 9 5 8. So what does this monotonic increasing stack will do? So it is going to insert the elements, like here it is going to insert 1. Okay, next time we have 7, so it is going to insert this 7. Okay, so it is going to increase. Okay, it is going to add the elements such that from the bottom if I move up I see all the elements greater than the previous one. Okay, so it is going to add 7. Then next time here 9, so it is going to add 9 in my monotonic increase stack. Next time I want to insert 5. Okay, so now if I insert 5, so here order will be disturbed now, from 1 to 7 increasing, 7 to 9 increasing, 9 to 5 it's decreasing. That is bad. So what it is going to do, it is going to remove the elements. Okay, so it is going to remove previous 9, then previous 7, then it is going to add 5. Okay, then after that, after 5 here it's going to add 8. So this is the final output for the monotonic increasing stack. So in monotonic increasing stack we have the elements in increasing order. Same way in monotonic decreasing stack we have the elements in decreasing order. Okay, decreasing order, right? So first we are going to add 1. Okay, then 7 we can insert. 7 I want to insert, but here's element is smaller now, that is not good, so I have to remove this one, and then I have to 7. Then I want to insert 9. Oh, this is smaller, so I have to remove it and pop it, then add 9. Okay, next is 5, so I will add that 5. Okay, because 5 is smaller than 9. Then next is 8. 8 is greater than 5, so I have to remove this 5 and then add 8 here. Okay, that's it. So I will get the monotonic decreasing stack. Okay, so here for this particular problem statement, okay, what is the definition of monotonic decreasing stack? I can say a monotonic stack is a data structure that maintains a specific order as elements are inserted. So in this case we need a monotonically decreasing stack based on the prime scores. Okay, meaning each new element can only be added if it has a lower prime score than the one at the top. Okay, so this definition you will get better understanding with an example. Okay, so you guys are clear with this particular example number one. Okay, so now let's come back to problem. Okay, so let's say this is my example. Okay, so first of all, you have to calculate the prime score for all these numbers. So for 60, if I write for 60 only, okay, so 230, here you get 2 into 15, and then you have to get here 3 into 5 and then 5. Okay, so 3 is the prime score. Okay, so here I'm writing 3. Same way you have to calculate for 15. 15 prime score is 2. For 420 prime score is 4. For 2 prime score is 1. For 40 prime score is 2. Okay, this is the first thing that you have to do in your problem. Okay, so in your problem, how you're going to calculate the prime scores? Okay, so for that you have to use this logic. Okay, this logic, so that's why I was explaining. Okay, so you have to run one loop. Okay, you have to run one loop. Okay, starting from 2. Okay, starting from 2 until square root of n, square of root of that particular number. Okay, so this is a reason for that. Okay, so until then you have to check, then you have to calculate the factors like this here. Okay, here, and you have to also do one final check. Okay, like this, and then you will get the prime scores. Okay, so this is the first step for your problem. Okay, once this is done, now after that you have to calculate the next dominant array values and the previous dominant values. Okay, so you have to create two array, next dominant and previous dominant, and then you have to add these values. How we are getting these values? This is your next question. Okay, so now let me show you that. Okay, so first of all, you are going to create two arrays of same size as your nums. Okay, so here let's suppose this is my next dominant array. Okay, next dominant array. Okay, so here this is my next dominant array. So that simply means that I want to find out. Okay, so here why we need that. Okay, why we need that. Okay, so here see why we need it. Okay, that is should be the next question here. Okay, so see in this particular example number one, so I was taking this particular sub array, right? I was taking this particular sub array, then there may be one more other sub array, okay, like this 9 and 3, in which also this number is going to be used in my result. Okay, and there may be some other array like here 938, in which this number is going to be used as my result. Okay, so I have to calculate the different sub arrays in which this particular element is dominant. Okay, in all these sub array, if you see, this particular element is dominant, right? This, the 9 is dominant, this 9 is dominant, this 9 is dominant, right? In all these sub arrays. Same way if you see in this particular example, so if I take this array, then also this is dominant. Okay, because prime score is 4. If I take this, then also this is dominant. If I take this, then also this is dominant. Okay, so I have to calculate the different number of sub arrays in which this particular number is dominant. Okay, so I have to do this for all the numbers. I have to find out in how many sub arrays this number is dominant, in how many sub arrays this number is dominant, in how many sub arrays this number is dominant, how many sub arrays this number is dominant, and in how many sub arrays this number is dominant. So this is what we need to do. Okay, so now here I have to calculate the next dominant. Okay, so this is index 0, 1, 2, 3, 4. Okay, so now here let's suppose initially I filled the values like this. Okay, I filled, let's suppose I filled the size of array. Okay, so in I said that for this particular number, the next dominant one is, okay, or you can refer this as well, for this particular prime score. Okay, for this particular subarray, whatever subarray that I'm going to create, that particular element which is dominant, let's suppose that exists here somewhere here. Okay, at index 5, that is nothing but the length of my nums array initially. Okay, initial case 5 5 5 5, I filled it like this. Okay, now here if you see carefully, for this particular number, okay, the next dominant number is at this particular position. Okay, so 3 is greater, 2 is not greater than 3, 4 is greater than 3. So here at this 0 I will just store the index of this 4. So I will add 2 here, I remove it, I add 2 here. This is done. Then for this 2, the next dominant, so in this side, so this 4, so that is also at 2 index, so I will add 2 here. Okay, then for this 4, there is no element now, so here I will remain it as it is 5 only. For this one, this is dominant. Okay, at index 4, so here I will add 4. Okay, this is done. 2 2 5 4 5, this is how you are getting this next dominant array. Okay, now here same way I want you guys to calculate the predominant. Okay, this previous dominant. Okay, so here let me write pd predominant. Okay, so how you're going to do that? Same thing. So for now I have to check in the left side now. Okay, predominant in the left side. So here let's suppose, let's take this -1. Okay, fill all the values with -1. -1 -1 -1 -1 everywhere. Done. Now for this one, if you calculate, okay, if you calculate, there is nothing, okay, in this side, so you will remain it as it is, okay, -1. There is no dominant element before this, okay. So for this there is this dominant element, okay. So if that means if I use 50 60, so I have to use this one, okay. So for this two, this is dominant one, so here at -1 I will write 0. Now for this 4, there is no dominant in the left side. For this one, this 4 is dominant one, okay. So this 4 is at index 2, so here at this 3 I have to write 2, okay. And same way for this 2 also I have to write 2 only, okay. So -1 0 -1 2 2. So this is how you are getting previous dominant, okay. So here I have shown you how you're getting these values, okay. But in code, how you're going to get that, this I have shown you how you're going to get these values, okay, by diagram representation. But in the code, how you're going to get that? So for that purpose, you have this monotonic stack property, okay. This is a data structure, not property, data structure, okay. So monotonic stack data structure you are going to use. All right, so now how you're going to use that, okay. So that's the next question. All right, so now let's suppose now you are clear with how we are getting this next dominant and the previous dominant. So let me just keep it here, okay. Now let me show you how we are going to get that, okay. Let me delete this, okay. So now let's suppose this is my monotonic stack, okay. This is my monotonic stack. All right, so now again start from here, okay. So at 0 index we have 3, okay. So now here you can create 2 arrays as well. Next dominant array, okay. Let's suppose this, and this is nothing but my prevDominant array, okay. So next dominant array and prevDominant array, okay. And here give the index 0 1 2 3 and 4, and same way here 0 1 2 3 and 4, okay. Here this is done, 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 okay. Now also now here you have to fill next dominant, you have to fill a max size 5 5 5 everywhere, 5 5 5. And here in the prevDominant you have to fill -1 -1 -1 -1 -1, okay. So now you have added this index, okay. So in reality you are adding the index only in monotonic stack, okay, index only. But here just for representation I have shown you this value as well, okay. So prime score was 3, okay. So next time you are going to add this 2, okay, at 1, okay. So this is what you are going to add to your monotonic stack, okay. So now this time, okay, so here this time if you see, okay, so for this particular you are adding this 2, okay. So let's say this 2, okay. So at the top of stack, first see at the top of stack. So at the top of stack what you have this 3, okay. And this 3 is greater than what you are adding now, okay. And you are using monotonic decreasing stack, okay. So you can add this, okay. You are using monotonic decreasing stack, okay. So in the decreasing format you can add the values, right, in the decreasing. So here you are going to add 2, okay. And now here you have to add 1, okay, at 1 index. So monotonic decreasing stack, okay. So in that stack okay, so this you can add. All right, so now here if this is the case, okay, if the existing value which is 3, okay, if it is greater than the new value that you are adding, that simply means that in the left side we get what, in the left side there is a dominant, okay. Predominant is there, okay. So what you have to do for this particular index 1, okay, you have to update the existing index, okay. So here you have to add at 1 you have to add 0, okay. So that's why you are getting 0 here, okay. Then we have updated 0, okay. So this is for the left side. Now after that you want to add 4, which is at 2 index, okay. Now here see carefully what is going to happen now, okay. So you want to add 2 at 4, okay. So now at the top of stack you have 2, okay, but you want to insert 4, and 4 is greater than 2, okay. So it's not decreasing, okay. It's not decreasing, we want decreasing, but here bigger element is coming. So that simply means we have to pop this, okay. We have to pop this. So if we are popping this element, okay, if we are popping this element, so what you need to do, so that simply means that there is one dominant factor, okay. So how we are going to update the dominant factor, okay. So this is the new element which is coming, okay. So definitely means that to its right, okay, to its right there is one dominant, because here this 4 is bigger now. So what you have to do here, here this is one nothing but index. So at 1 index you have to add this value, okay, 2, So here at this you have to add this 2 and you have to remove it. Okay, done. Then same way here also this 4 is greater than this 3, so we are not going to add like that, right? 3 to 4 we have to add decreasing order, right? So in that case also add this 0, you have to update the new 2. Okay, so you have to add 2 here. So this is done, and then you have to add index 2 and 4 here. Okay, this is done. Okay, then after that here comes 1 at index 3. Okay, so now here we can add this 1 and 3 index. Okay, because we need decreasing order, right? So if we can add easily, okay, without popping any element, then we have to update the PD. Okay, this prevDominant. Okay, so what I'm doing, add 3. Okay, there is one previous dominant which is at 2. Okay, so here I will add 2 here. Okay, done. Now after that this comes we want to add 2 which is at 4. Okay, so now here it's increasing now, so then we have to pop it. Okay, so we have, if we are popping it, so that simply means what we are doing, so we want to pop this 3 1. Okay, so that simply means there is one dominant factor here. Okay, at 4. Okay, so here I will add the index of this, so here I will update 4 and then I will just remove it, and then if I can add this, right, 2 4. So here if I'm adding that, so what we need to do, we have to add 4 to first. Okay, so here I'm adding 4 comma 2, and then at 4 index we have to write this 2. Okay, because there is one dominant in the left side. Okay, so in the end you will get like this 2 2 5 4 5 and minus 1 0 minus 1 2 2. Okay, so this is the logic. Okay, so what you guys need to do here, you have to open one copy pencil. Okay, and in that when I'm going to write the code, just note the code and just try to do the same thing that I did here. Okay, and then you guys will get much better idea. Okay, with code you get much better clarity. Okay, when I'm going to write the code. Okay, so here I have shown you what is going to happen. Okay, and we are getting the same output for the next dominant and previous dominant. Okay, but still you have to practice it. Okay, you have to make note of it, how you are going to do this. Okay, you have to draw all these diagrams by yourself, and then you have to put your cursor here first. Okay, I loop. Okay, and then you have to do all these steps. Okay, so you have to debug in your copy pen pencil. Okay, using copy pen pencil. Okay, so this is what you need to do here. Okay, and you're going to get this. Okay, so this is clear. Until here we are clear, we get the next dominant and previous dominant. Okay, so now this is done. Okay, so now after that we have to do one more thing here. Okay, so this is done, right? So after that what you need to do, we have to calculate in how many sub arrays, uh, the element which is at particular index is dominant. Okay, this is what we need to calculate. Okay, so in how many sub arrays this particular number is dominant. So for that, how we going to do that? Okay, so that's the next step. Okay, next question. Okay, so how we do that? So let's suppose I want to check here in this particular example, in how many sub arrays 9 is dominant. Okay, so if you see here in 3 sub arrays only, right, 9 9 3 and 9 3 8, in these 3 only 9 is dominant. Okay, so how we going to do that, how we are going to do that? Okay, so this is what we need to know, calculate now. Okay, so using this next dominant and previous dominant I can check that. Okay, so here, okay, so what is my array? 60 15 420, 60 60 15 420. Okay, and 2 and 40, 2 and 40. Okay, and prime scores 3 2 4 1 2. Okay, 3 2 4 1 and 2. Okay, and if I write the index in here, 0 1 2 3 4. So right now if you see, this 420 is going to be dominant in how many sub-arrays? So there is a formula for that. Okay, so here can I write sub-arrays for that? Can I write that? So here if you see, if you pick this particular sub-array 60 15 420, then this 420 is dominant. Okay, because prime score is large enough here, right? This is done. Then also if now you can write here 60. Okay, let's say I'm starting from 60 only. 60 15 420 and 2. So in this also this is dominant. Okay, this is dominant because of this prime score. Then same way 60 50 420 2 and 40, this is again. Okay, 3 here done. Then after that 15 420 you can write 4. Okay, then you can write 15 420 and 2. Okay, then you can write 15 420 2 and 40. Okay, 2 and 40. So how many we did right now? Let me count. 1 2 3 4 5 6. Okay, And then here from 420 if I start, so 420 once just this 420, then 422, okay, then I can use 420 2 and 40, okay, so here 7 8 9, and that's it, I think so, right? 2 and 40 we can't use because 420 is the max, okay, so using this 420 I want to calculate, right? So this is done, okay. So how many 9 are coming up? So using this, can I calculate that using this? So 420 is at index 2, okay, so at index 2 we have next dominant is 5 and pre-dominant is -1, okay. So from here if I do the next dominant, okay, next dominant, and here I subtract this particular index which is 2, okay, next dominant particular index, okay, this, and if I do I, okay, and this I index minus predominant value at this particular index I, okay, next dominant of I, predominant of I, okay, so next dominant of I value is 5 minus index is 2 into I is 2 minus plus 1, okay, this is done. 5 minus 2, 3 into 3 is equal to 9. I'm getting 9 only with this formula, and here also if I see I get 9 only. But now let me prove how this 9 is possible, okay. So now see this, so this is our array, right? 60 15 4 22 and 40. So for I is equal to 2, okay, index 2, so this is 0 index 1 index 2 index 3 index and 4 index, okay. So I is equal to element is 420, so next dominant 2 value is 5, okay, which we had already calculated using monotonic stack, and pre-dominant 2 values -1, okay. So to form the formula to compute the number of sub-arrays where element at index I 420 is dominant is, this is the formula that I have shown you, right? I minus pre-dominant, I minus predominant of I into next dominant of I -1, okay. So this is the formula. Now if we substitute the values we get 9, okay. This is this we already know. Now how this is working, okay. So first we are determining the left boundaries. So the left boundary of subarray can be from in start can be any index from predominant of I +1, so here -1, so from +1 if I add, so I will get 0 to 2, okay. So 0 2, so from 0 index to 2 we have different boundaries, okay. So I can use this as boundary, I can use this as boundary, I can use this as boundary, okay. So I have these three options here. Now so valid left boundaries are indices 0 1 and 2, okay. This gives us three choices. Now for right boundaries, so from I is equal to 2 to next dominant of I -1, so 3 4 5, okay, index we have. So here these three are our choices, right? This is done. So valid right boundaries are indices 2 3 4, okay. So we have to use 2 3 4, right? 2 3 and 4 here, okay. So from 2 it is starting, right? 2 to next dominant of I -1, okay. So 2 3 4, okay, these are the choices, okay. Now here how we are going to calculate sub-arrays, so this is like this now. So one choice you can say like this, okay, then 2, then 3, okay, this is done. Then same way from here you can start, right? First time you did this, okay. Then after that again you start from here and until here, okay, again here, again you have 3, then from here start 1 2, then again 3, okay. So this is how you have to go, right? Each combination of left and right boundaries form a valid subarray where 420 is the dominant element. Since we have 3 choices for left boundary, 3 choices for right boundary, so that is why we are doing multiplication. So this is listing all possible subarrays. So 420 if we take this and this, okay, then 422 422 40, okay, all this stuff, okay. So this is what we are doing, right? So the formula, this is going to correctly count the number of subarrays where the ith element is dominant, right? So this is, we have already verified with this particular example, okay. This is done. So now this is also done. Now after that what you need to do, okay, after that it's very simple, okay. So what we have to calculate, we have to calculate a k na. So here where is my example? So yeah, so for this example whatever the k value is there, okay, number of operations that you have to calculate. So now you know that 420 is dominant in 9 subarrays, okay. In 9 subarrays 420 is dominant. So if my k value is 9, so you can simply do one thing na, you can simply write 420 and you have to multiply it with 9 times na. So 420 power 9, you have to do this, right? In 9 operation, if my k value, let's suppose it is 9, so then you have to, for first operation you have to write 1 to 420, then next operation you have to write 420 to 420, okay. Then next operation whatever the value result that you are going to get, let's say a, in that also you have to write 420 for k is equal to 3, okay. This is k1 k2 k3, okay. So until 9 we have asked, then we can simply write 420 per 9 na. So how this has reduced, right, our problem. We can simply do this, okay. We already know that in how many sub arrays this is dominated, so we have to use distinct sub arrays every time. So if k is equal to 9, so I can easily form 9 sub arrays in which my 420 is dominant, okay. Then after that once 420 is done, then after that I will check for this particular number na, where this 60 is dominant, okay. This is larger number na, then if my k is equal to 12, let's say, then for k until 9 I will check with this, then after that I will proceed with checking with 60, then I will proceed with 40. Okay, so this is also we need to do, right? So here also we have to use one priority queue. Okay, and based on these numbers, okay, like 420 I will check first, 420 adds 2. Okay, so I will just add this number in my priority queue, and based on this I will just create, okay, I will just use a priority queue, okay, based on this one. Okay, so this is the next thing that we have to do once we calculate everything. Okay, so in the priority queue we have to process the elements in decreasing order of their value. Okay, so and one more thing, if let's suppose for two values are same, 420 420, then you have to choose the one with the small index. Okay, you can do that. Okay, so this is also done, right? So now after that, once this is done, okay, that's it, basically that's it. Okay, now here what we were doing, we are doing 420 multiplication, let's suppose 9 times. So this is very big now, 420 per 9. How you are going to solve this? 420, you are going to do like this, 420 into 420 into 420. Okay, this is very big number. Okay, so there is one way to solve this. Okay, and that way we can say that as there is one naming for that one. Okay, binary exponentiation. Okay, binary exponentiation. Okay, so how we do that? So here let's suppose you have number like this, 2 power 6 you have to calculate. So it's very easy, right? You can easily calculate 2 into 2. Okay, 2 into 2 into 2 into 2 into 2 into 2. Okay, so 2 into 2 4 4 2 12, 8 8 to 60 62 32 32 to 64. Okay, you are going to get 64. Okay, but here let's suppose the number is very big, 60, then it's a problem now. Okay, so instead of checking in of n time complexity, there is one shortcut to check all this in of log n time complexity. Okay, so how you have to do that? Okay, so let's understand this with some simple example. Okay, let's say 2 power 6 only. Okay, and you have to check that in of log n time complexity. Okay, instead of doing like this. All right, so here I can write this like this as well. Okay, 2 power 3 square, I can write it like this as well. Okay, so here what I'm doing, I am writing like this now, 2 power 3 into 2 power 3. Okay, so here what I'm saying, first just calculate this video and then just do the square. Okay, so here 2 power 3 you're going to get 2 into 2 4 4 into 2 8. So I'm saying take 8 and then just multiply this 8 with 8 itself, and you get the output 64. Okay, so here I just calculate for this one only, and then I just multiply it with the okay, with itself. Okay, I get this. Okay, this is one way, right? So here if let's suppose 2 and here it is an even number, then I can do like this, 2 6 power 2 into 2. I can write it like this. Okay, if this is my exponential, right, it is my base. Okay, so if my exponent is even, okay, then I can do like this. Okay, but if it is my exponent is odd, okay, then I have to write, I can write it like this now. It's a basic math property, 2 into 2 power 6 by 2 into 2. Then I can write it like this, right? Right, so this is nothing but 2 power 7 now. So here you have to get 2 into 2 power 3 into 2 power 3 again. Okay, same thing now, it is nothing, 2 power 7 only. Okay, so in case of odd exponent, I have to just take one base here and then again multiply it with this remaining. Okay, so this is what we need to do, right? So I'm going to use this logic actually to calculate this in of log n time complexity. Okay, so that is the reason this problem is a little bit hard, right? There are a lot of things in this problem. Okay, you have to think a lot of edge cases right here, right? So okay, this is one more thing, and one more thing, if your exponent is 0, then always result is 1. This I already know. Okay, so much math is there, right? If your exponent is 0, then this is 1. Okay, so what you are doing here, you are dividing the number in half always. So here 2 is 6, so you are dividing it in half. 2 power 3 the square. Okay, so you are doing like this now, 2 power 6, so you are dividing it in half. That's simple, 2 power 3 and 2 power 3. Okay, 2 power 3 here, then here you have to write it. Okay, so here if it is a odd, okay, now power is odd, so you have to write it like this, 2 uh, again into half you have to write, so you are going to get right 2 here. Okay, 2 into 3 power 3 2 into 2 power 1. Okay, 2 only you have to write. Okay, here, right, again you have to do it in half, right? So here you have 2 power 3 now, so here you have to write 1 2, and here you have to write 1 2. Okay, and whatever the result you are going to get, in that you have to add a 2. Okay, multiply 2, right? So this 2 3 I'm going to write it like this here now. Here I can write it like this, 2 into 2 power 2. Okay, I can write it like this because this is odd. Here also 2 into 2 power 2. Okay, I can write it like this. Then from here 2 power 2 I will split it like this, 2 2. Okay, and okay, this is done. 2 power, this is 1. Okay, this is 2 power 1 only. So here also I can write 2 power 1 into 2 power 1. Okay, this how I'm going to split, and here this 2 is there. Okay, this I haven't solved yet. Okay, then again here if you again, this is nothing but you can write it like this. Okay, 2 power 0 and 2. Okay, 2 power 0 0.2. Okay, that simply means simple 2 only na. Okay, this is also simply means 2 only. Okay, done. Now from here 2 power 0 you already know 1, 2 power 0 1, 2 power 0 1, 2 power 0 1. So from here you are returning 2, from here you are returning 2, 2 into 2 4, 2 8. Okay, so you get 8 here. Okay, same way you are going to get 8 here, and 8 into 8 you are going to get 64 here. Okay, this is recursion diagram. Okay, with code you get much better understanding, but this is the logic that I'm going to use. Okay, so now let's move to the coding part. Okay, and in the code also I'm going to write all the things whatever I have explained. Okay, step by step. Like first we have to create this prime factor score. Okay, so here prime score we have to calculate. How we do that? Okay, all that stuff I'm going to do, right? So now let's just move to the coding part. In the problem statement given that the size can be very large, so for that you have to use modulo, right? So final int mod, okay, mod is equal to 10 power 9. So 1 1 2 3 4 5 6 7 8 9. Done. Okay, then here inside this calculate the num size. Okay, nums dot size. All right, and then create one list of integers. Okay, list of integer, and here prime scores. All right, and here new array list. Okay, and in this array list, you inside this you can write collections dot n copies. Okay, and here you have to write n comma 0. Okay, all right. So now what you have to do, you have to calculate the prime scores for each number in a nums. All right, so here you have to write for int index is equal to 0, index is less than n, index plus plus. Okay, so this is done, and then just get that particular number. Int num is equal to nums dot get that particular index. Okay, this is done. Then we have to check for the prime factors from 2 to square root of n. Okay, so I have already told you why until square root of n. Okay, so for int factor is equal to 2, and here factor it should be less than equal to math dot square root of this particular num. Okay, and then after that here you have to write factor plus plus. Okay, done, right? And then after that inside this you have to just check if num modulus with factor. Okay, if it is equal to 0, then in that case we have to increment the prime score for each prime factor. Okay, so if that, let's suppose 2 is divisible completely by 24, then 2 is one okay, prime factor. Then 3 4 5 we have to check. Okay, okay, simple. So here what you have to do now, we have to increment the prime score for each prime factor. Okay, so here I will use prime scores. Okay, so from prime scores, okay, we have to set. Okay, and here I will get that particular index. Okay, and in this going to prime scores. Okay, and here dot get that particular index. Okay, so add that particular index, I will just add 1. Okay, so that is nothing but the prime score of that. Okay, and now here I'm going to run one while loop, because for 2 like we were doing now, if we are dividing it with 90, then here, then after that until 45 we have to stop now. Here 45 we are stopping, right? 45 we are stopping, right? So we have to check this. Okay, we don't want to calculate two times. Okay, in the prime score. So here num modulus factor. Okay, if it is equal to 0, okay, then you have to do here num is equal to num divided by factor. done. Okay, so this is done, and here this loop ends. Okay, this ends, and if a number is still greater than or equal to 2, then it's a prime factor. Okay, so here, like in this case, we have to check this. Okay, number is greater than equal to 2, right? So here, if num is greater than equal to 2, okay, then here you have to write prime scores dot set, okay, index, and here prime scores dot get index plus 1. Okay, this is done. All right, so this is done here, and this ends here. Okay, so this is very simple loop, right? Very simple loop. Okay, so first we created one array list of prime scores, right? Okay, and after that, what we did, we are iterating over all the indexing one by one, right? And then we get that particular number. Then for that number, we are checking the different prime factors. Okay, and for those prime factors, we are incrementing the count. Okay, prime scores. Okay, so this number is at index 0, so at 0 index for that particular number, we are checking the what is the prime scores. Okay, so we are calculating that, and if number becomes greater than equal to 2, okay, in the end still it's greater than equal to 2, then again we have to increment one more prime score. Okay, so this is done. Okay, done. Right, now after that, we have to initialize. Next step, we are moving to the next step. We have to initialize the next and previous dominant index arrays. So for that, create array int. Okay, and then here you have to write next dominant new int n. Okay, new int n. Same way, you have to calculate, you have to write one more, create one more array prevDominant. Okay, so copy this, paste it here, and here let's name it as prevDominant. Okay, now this is done, and also initialize the value. Okay, you have to initialize the values as well. Okay, so here arrays dot fill next dominant. Okay, and here you have to write n. Okay, with n you have to fill all the values in the next dominant, and same way in prevDominant you have to add -1. Okay, so here prevDominant, and you have to add with -1. Okay, this is done, right? Then we have to use a stack to store the indices for monotonic decreasing prime score. Okay, so for that I'm going to create one stack. Okay, so this is step 2 done. Okay, step 2, yeah, it's starting just now. Okay, so now we have to create one stack. Okay, stack, and in stack what I will add, I will just add the integers. Okay, integer. Okay, and here you can say decreasing prime score stack. Okay, decreasing prime score stack. All right, and here new stack. All right, okay, now inside this we have to calculate the next and previous dominant indices for each number. Okay, so again run one loop for int. Okay, now in this step now, for int index is equal to 0, index is less than n, and index plus plus. All right, and then we have to run the while loop. Okay, while the stack is not empty and the current prime score is greater than the stack stop element. Okay, so for that purpose, here we have to write while. Okay, and here this particular stack, okay, this decreasing prime score stack, okay, if it is not empty. Okay, so is not empty, so is not empty. Okay, if it is not empty, and okay, prime scores dot get. Okay, so from my this, okay, prime scores dot get this. Okay, from the peak. Okay, from the peak of the stack, whatever the value. Okay, so if this value is less than the new value that I'm just going to add. Okay, so here prime scores dot get, okay, index. All right, so new value that I'm going to add. Okay, so here if this is the case, then top index is equal to decreasing prime stock stack dot pop. Okay, I have to remove that. Okay, and if I am removing that, then in that case we have to set the next dominant element for the popped index. So in that case we have to write next dominant. Okay, and here top index is equal to index. Okay, all right, so this is done. Now if the stack is not okay, this is done, okay, for this particular part. Okay, now if the stack is not empty, okay, then we have to set the previous dominant for the current index. Okay, so if we are not removing, then in that case, okay, so here again run one if condition. Okay, and here just write if this decreasing prime score stack, okay, if it is not empty. Okay, and now in this case what we have to check. Okay, then if it is not empty, right, and then in that case you have to just update. You can use right like this. Okay, prev dominant. Okay, oh, and here you have to write index. Okay, that index you have to update with decreasing prime score stack dot decreasing prime score stack dot peak. Okay, you have to update with this. All right, and now once this is done, and we have to push the current index onto the stack, right? So here decreasing prime score stack, right, dot push. Here we have to add index. Okay, so this is what we did here. Okay, when we created the stack, okay, one by one. So this is what we were doing here, right? So this is the done for this. Okay, so we are going to calculate this. Okay, next dominant, prevDominant. All right, with this code, that's it. Now we have to calculate the number of subarrays in which each element is dominant. Okay, so now for that we have calculated the number of subarrays, right? So long create one more array, num of sub arrays is equal to new long, and here you have to write n, and then inside this again run one loop. Okay, for int index is equal to 0, you can just copy this. Okay, for int index is equal to 0 and index is less than n index plus plus, and here num of subarrays num index. Okay, you have to calculate this. Okay, so here the formula that we have derived, right? So here you have to write since the values can be large, right, here also. So here inside this just change type to long. Okay, and here the formula that we had derived. Okay, so next dominant. Okay, and here you have to pass index. From this you have to pass the index particular, right, and then you have to multiply this with the index minus prev dominant. Okay, and here inside this you have to pass the index. Okay, so this is done here. Okay, all right, so this is ending here, this is ending okay, this is ending here. All right, okay, and this is for this only. Okay, long of next dominant minus index. All right, and can I keep this? Okay, now it's look good only, right? Okay, so now after that once this is done, then we have to use the priority queue to process the elements in decreasing order of their value. Okay, so we were also using that concept, right? So first like 420 was bigger number, so we have to use that, right? So here priority queue, and in the priority queue pass array, right? And here let's name it as processing queue. Processing queue. Okay, and here new priority queue. Okay, and here inside this let's say we have two parameters. Okay, a comma b. All right, take it like this, a small b small. Okay, a comma b we have. Now how we are going to use our priority queue, right? So here if element b, okay, 0 index. Okay, if element b 0 index, okay, if it is equal to a of 0 index, all right, then in that case we have to return integer dot compare. Okay, and here we have to add a 1 a1, and here we have to add b1. Okay, this is done. So what we are doing, we are breaking the tie based on the index. Okay, ascending order, right? And if that is not the case, then we have to descending order for the value we have to do, right? So in that case here you have to write if this is not the case, then you have to return integer dot compare. Here you have to write b0 and a0. Okay, so here b0 and here you have to write A0, A0. Okay, this is done, right? And this is where your priority queue ends. Okay, that's it. Then after that we have to push each number and its index onto the priority queue. Okay, that is going to be the next step. All right, so here for int index is equal to 0, index is less than n, index plus plus. Okay, and here processing queue dot offer, and here after that you have to write a new int. Okay, and then what you are going to pass in the priority queue, first you have to pass the value. Okay, so nums dot get. Okay, so nums dot get, first pass the value, right, instead of index. Okay, in the example I've shown you first index, okay, diagrammatically, but here you pass index first. Okay, in the priority queue, and then you have to pass index. Okay, that's it. All right, so this is done. Okay, and then after that initially score is 1. Okay, long score set it to 1 only initially, and then we have to process the elements while there are the operations left. Okay, so here you have to run one while loop while k is greater than 0. Okay, we have to get the element with the maximum value from the queue. Okay, so for that take the topmost element first. Okay, into top, and here processing queue. Okay, dot poll. All right, now after that take num is as top. Okay, value we need, so top 0 index we have value, and the index we have at top 1. So here top of 1, very big code, right? I will add the code in the comment section. Okay, then we have to calculate the number of the operations to apply on the current element. Okay, so number of operations we have to calculate. Okay, number of operations is equal to math dot min. All right, and inside this whatever the value, okay, k value, okay, whatever the minimum value, that much operations we need now. So long of k or number of sub arrays at this particular index. Okay, so number of sub arrays. Okay, number of sub arrays that we can form. Okay, we have already calculated now. So at this particular index, okay, whatever the minimum among them, we have to take that. Okay, and we have to multiply that with the score now every time. So here this is done. Then after that we have to take score here. Score is equal to score and multiply by the, okay, so I will call one power method. Okay, here the power method that I've already explained for this binary exponentiation, right? So here power, in power I will just pass the base value. Okay, that is particular number, and operation is nothing but the exponent. Operations done, and this is going to give me a very big value. Okay, I'm expecting that. So here I will just use the mode now. Okay, the mode that I've created starting, right? This is done. Then we have to also reduce the remaining operations count. Okay, so we are almost done right now. Okay, so k minus equal to, and here I will write operations. Okay, number of operations we decreased, and that's it. And here we have to just return score. Okay, return type is int. Okay, so for that purpose I'm writing like this. Okay, this is done. Now just few things is pending, that power. Okay, that's it, this power. So this is very easy code for this. Okay, helper method I will create helper function to compute the power of a number modulo more. Okay, so we have to calculate the exponentiation using the binary exponentiation. So I can use a recursion here, simple. Okay, so private long power, and here you have to pass a long ab. Okay, let's pass base and exponent. Okay, long base, long exponent, exponent. Okay, now after that here one base condition. Okay, if exponent if exponent okay, exponent if becomes equal to 0, then you have to return 1. Okay, so 2 power 0 or any base power 0 is always 1, so that's why this is my base condition. Okay, and every time what we are doing, we are calculating the half now. So how we are calculating the half? So half, again you have to call this power function only. Okay, power method only. Okay, so in this your base will remain as it is. Okay, base is not going to change, but your exponent you have to divide it with 2 every time. Okay, so this is what you are doing now. You have every time you are dividing it with 2, right? And you have to, how you are calculating the result? You are calculating the result as half into half now. So here you have to write half into half. Okay, and here also I'm expecting very big value, so here I will just do the with the mode. Okay, mod. All right, now here one more thing now. So if your exponent is odd, okay, that's also one thing that we have to check now. If exponent I'm dividing with, okay, with 2, and I will get 1. Okay, remainder 1. So in that case also this what we have to do, we have to update the result as So whatever the result value that we have, okay, in that again I have to add one more time one base, okay, so that I will include that. Okay, so like 2 power 7 we are writing, how we are writing, okay, 2 power 7 we are writing 2 into 2 power 6, okay, so that's the so one base we are taking and the result of 2 power 6. Okay, so here again do the mode. Okay, now that's it. Okay, this is done, and from here you have to simply return the result. That's it. Okay, so now let's run the code, and I'm expecting a lot of issues. Let's see how many spelling mistakes or code issues. Let's see. So there are some, right? So first where it is, I should be small, right? Now again let's run it. So there is some issue, right? So now let's try to find out that. Okay, so this should come outside, right? It should not be here. That is the reason I think we are getting the issue. So let's fix this and see. So here my for loop ends. Okay, and here I will just check for that particular number. If number is still greater than equal to 2, then I will add again one more add, okay, to this. Now let me just format the code and let's run it again and let's see. So the test cases has been accepted. Wonderful. Now let's submit it. So see, our solution is accepted, right? So I hope that you guys are able to understand today's problem. And if you guys still have any doubts, then please feel free to ask in comment section. Till then, keep coding and keep practicing. Meet you guys in the next video. Thank you. Bye bye.